Once again, members, we are having this video which says find the maximum and minimum values of 2 sine theta minus 5 cos theta and values ranging from 0 to 360. We are using the form of a cos theta plus b sine theta. That form you can check in the previous video I had made concerning this formula. Now, if you look at the cos theta plus sine theta, this is the form we are going to use. But if you look at this sine theta minus cos theta, from the identities of compound angle, which I wanted you to know, that I'm going to actually use this identity is the one which can bring out what I want, the sine m minus b, because I have a cos then minus a sine somewhere, so I can't use this one because it has a plus and this one has a cos. So the suitable identity to use is this. So what I'm going to do, so from sine a minus b, which gives me sine a cos b minus cos a sine b. Now instead of a and b, this time I must have theta and alpha. So it will be sine theta cos alpha minus cos theta sine alpha. So it is in this form that I'm going to be able to use. Now I'm going to compare the original and this one. So I will have 2 sine theta minus 5 cos theta to equal to k, my constant, and the whole of this sine theta cos alpha minus cos theta sine alpha. Now opening the brackets, theta minus 5 cos theta will give me k sine theta cos alpha minus cos theta sine alpha. There is a k here. If I try to put the k in the brackets, so I will compare this side to this side and this side to this side. So I will have 2 sine theta equaling to k sine theta cos alpha, of which I'll be able to get 2 equals to k cos alpha, and also the other side I'll be able to get 5 cos theta minus is equal to k cos theta sine alpha, of which I'll be able to get 5 equals to k sine alpha. If this is my equation 1 and this is my equation 2, dividing equation 2 by 1, I'll be able to get tan alpha equals to 5 over 2. Now getting alpha, I'll be able to use arctan of 5 over 2, which will give me alpha as 68.20 degrees. Again, using Pythagoras theorem, you know tan is opposite of adjacent. This is 5, this is 2. Getting this side, if I use Pythagoras theorem, I'll be able to get root 29, the hypotenuse. So therefore my cos alpha will be 2 over root 29 and sine alpha will be 5 over root 29. I hope you are following up to this step. Now I'm going to bring this original one, and since I have the k, I'm going to replace it. So I have 2 sine theta minus 5 cos theta. It will equal to the root 29 into 2 over root 29 sine theta minus 5 over root 29 cos theta. Now this one, I'm following this with the k having it already. So this one was the same as root 29 of sine theta cos alpha minus cos theta sine alpha. So I don't want you to get lost. The cos alpha is this, and the sine alpha was this, but I already got them. So this one will be root 29 sine of theta minus alpha. If you try to go to the base where this came from, it is this when you expand it. So now I'm almost concluding this question. I will say, remember I have this, the greatest value of sine x is 1, and it occurs when x is equal to 90 degrees. And also the least value of sine x is -1, and it occurs when x is 270 degrees. The values of x less than 0 or greater than 360 have been ignored at this point. So I will say, therefore, root 29 sine theta minus alpha has a maximum value of root 29 when theta minus alpha is equal to 90 degrees. And also the same, the minimum value, of negative root 29 when theta minus alpha is equal to 270 degrees. Now I'm concluding. Therefore, the minimum and maximum values of 2 sine theta minus 5 cos theta are